All right, so now we're 13.1, task 2. So now we're still discussing the aquarium problem, so the aquarium and the number of visitors, but now here we have two different models. We have Megan, who she based her model based on the ratio of the V values of the first two data points, meaning she looked at that ratio between the first 2 points, 0.1 and 0.0, that 1.22, and that's what she used. Like we used a number in between, 1.15. She used 1.22. Okay. And then over here we have Austin's model. He averaged all of those values. So if we go to our table, he actually averaged them, which we can average them real quickly. If I just start typing in equal and AV, it pops up with average. So I want to average. Now I highlight the columns. I want to average these. So this is the average of cell C3 to C7. So it averaged this one to this one. And we get 1.1956. So, and he rounded that to 2 decimal places. So he used 1.20. Because if I round that to 2 decimal places, that's 1.20. Okay, so let's go ahead, let's delete that column. Okay, so we want to figure out which one of these models is the best fit. And we're going to do that using something called a residual. Okay, so, and we're going to use our calculator to do it. So what a residual does is it basically looks at, so I'm going to go ahead and I'm going to delete all of that information I had in that column so we can come up with the residual. So this was the actual information. So I'm going to put that up in the heading. So this was the actual output. We're going to go ahead and let's look at Megan's first. And let's do the V, but the predicted V. Predicted. Using her model. Meaning, based on her equation here, we're going to input the 0, 1, 2, 3, and then see how they compare. Meaning, I'm going to take her equation, so I'm going to plug in equals, and then her equation is 250 times, so times, you go shift, it's 8, it's that little star, to get the times, and she took 1.22 to the x. So we're going to do 1.22, and then to get the 2 we hit shift 6, so there's our exponent, and this is going to be my new exponent. So when she puts in a 0, she does get 250. Okay, but what happens when she puts in a 1? Now, I could do all of this calculation in my calculator, but I don't have to. I can use Excel and just click and drag down. So this is what her model got when she plugged in a 1, which makes sense because she used the ratio from 0 to 1 to get it. This is what her equation got when she plugged in a 2. If you notice now, it's different. Should be 350, she got 372. She's a little big. And this one's a little big as well, so forth and so on. To figure out how much larger, we're going to create a column called the residuals. And basically, it's how much larger. Again, let's center that to make it pretty. Okay, let's go ahead and let's center that one to make that one pretty. Is the residual is the difference between the two columns. So enter, it's the predicted. No, it's the actual other way around. Sorry, guys. It's the actual minus the predicted. Let's see what we get. So the 0, so that 0, again, I can just click and drag down. So there's the difference. So here, her model was 22 too high. Okay, so the actual was 22 smaller than what she got. And then here it was 33 smaller than what she got. Okay, let's say I don't want all of those crazy decimals. I can actually highlight, and if I right click, okay, oh, I thought, format cells, yep, click format cells and go here to number. I can say I want it to round it to no decimal places, to just go to whole number. And it's going to round it all to the nearest whole number. It does use those our rounding rules, and it rounds it how it's supposed to. So I can make my data look less confusing. But again, I have to know, hey, that's rounded. Okay, and then And then a trick that we use is something called the square of the residual. Because why we square it, so here let's do the square of residual. Let's make this column larger. I just put my cursor in between the E and the F, drag it over so that the whole words fit. So now the square of the residual, basically what taking the square is going to do is it's going to make it positive. So I want these to be positive. So I want to take this number and square it, take it to the second power. So again, let's make it centered, make it pretty. And if we click this and click it down, it's just taking this number times itself. Okay. And so to compare, a quick-ish way to compare two models is we come up with this sum. So we are now in this last column going to sum or add up, see there's a nice sum option, all of these residuals. The closer this sum is to 0, the better the fit. Okay, so the closer this sum is to 0, the better the fit. Okay, so this was for Megan. Now, this was for hers. Now we're going to go ahead and we're going to use Austin's here in a minute. But I want to show you some shortcuts on that. So first, if you notice down here in the corner, it says sheet 1. I'm going to go ahead, right click, and I'm going to rename this sheet Megan. And I'm going to hit this button here to create a new sheet. So what I can do is I don't have to do all this over again. I can click up here in the corner to select all of it. Clicking up here in this box selects all of it. Hit Command C or right click and go copy. Copy. Arrow over to sheet 2, click up here in the corner and paste. Now I'll need to zoom back in again. Now here I've got a whole nother sheet. But I can now use what I've got. The only thing that changed, let's rename this, right click, rename. Let's rename this one Austin. The only thing that's changed in this one is the equation he used. If we reference our notes again, he used 1.20 to the t. He used the average of all of those ratios. So instead of using 1.22, we're going to use 1.20. So I can come up here to this and change this to 1.20 to the t. Now I will have to click it and drag it down again. Do you see it automatically changed everything that was already in there? I didn't have to redo, just automatically changed it. So now we see the square of the residual. So when I take this residual, again, this residual is just the difference between the actual and the predicted. Okay, let's go ahead and let's put that in our notes. The residual, it's the predicted value, subtracted from the actual value. We already have that in there. So it's the predicted value subtracted from, so it's actual value minus predicted value. It's not a huge deal if you get them mixed around because we square them. Really, if we got them mixed around, it would just make positive 10, but we square it, which makes it positive. And here's the sum of the squares. Sum of the squares was 426 for Austin. This last column here for Megan, the sum of the squares, was 7,463. So Austin's was closer to 0. Austin's sum of his squares. So since Austin's sum of the squares of the residuals was closer to 0, his is the better fit. So it's kind of like looking at that correlation coefficient, but instead we're using a residual instead.